morning, students. Today we are going to discuss about induction heating. Okay, so induction heating is based on the principle of transformer working. Very important objective type also. Induction heating is based on the principle of transformer working. Already we know the transformer working, so that the same principle we need to apply here. Okay, once recall that transformer principle, that is an MI, mutual induction. When a current is passed through one coil, the flux is established in the second coil due to that of an MI. The same principle will be applicable here. Okay, the primary winding which is supplied from AC source is magnetically coupled to charge, which acts as a short circuit secondary of the single turn. Okay, the principle the principle used in the transformer, the same principle again you have to apply here. Okay, when AC voltage is applied to primary, it induces a voltage in the secondary. Okay, considering a two coils, coil A and coil B, the supply is given to the coil A, then after the flux will be established in that second coil due to that MI principle or transformer principle. Okay, now see here, if V is the voltage induced in the charge, if V is supply voltage in the charge and R is the value of resistance, then the heat produced V square by R. H is equal to, then the heat produced any device, heat produced H is equal to V square by R. Okay, the value of current is induced in the charge depending upon the following parameters. The value of current induced in the charge. So now here the charge is depending upon some parameters. That parameters are, first one is that magnitude of a primary current, second one turns ratio of the transformer, coefficient of magnetic coupling. These three parameters is including in transformer only. That is an, once again I am repeating, that is an magnitude of primary current, turns ratio of the transformer and coefficient of magnetic coupling. Okay, now see here, low frequency induction furnaces is employed for this metalling of the following types. Generally these are that low frequency as well as high frequency. Already we are discussed in that methods of an heating, that is a low frequency methods are there and high frequency methods are there. Similarly now here induction type is the low frequency. Now I am going to be discussed. Now here low frequency induction furnaces is again classified majorly two types. Majorly two types. Those are core type furnace and coreless type furnace. Very important. These two, induction furnace, low frequency induction heating is mainly broadly classified into two types. Those are core type furnace and coreless type furnace. Okay, now first keep heading. First one, core type furnace. Again this core type furnace is further classified into three types. Again core type furnace further classified into three types. Those are direct core type furnace, vertical core type furnace, indirect core type furnace. Okay, these are the three types. The core type furnace is classified three types: direct core type furnace, vertical core type furnace, indirect core type furnace. Okay, now we will discuss about one by one. First one, keep heading, direct core type furnace. Direct core type furnace. See that this is a picture about direct core type furnace. See that the picture is consisting of an supply, primary winding, and next the charge of the device. Okay, now see here, as shown in the figure, this figure is consisting of a single turn short circuited. Now here consider, see that figure. So based on the explanation we have to express in depending upon diagram only. The diagram is consisting of only as a single turn. Okay, single turn and short circuited secondary. There is no winding for secondary. Is magnetically coupled to primary is an iron core furnace. It consisting of a circular circular height which consists of a two charge of metallic in the form of an angular ring. Okay, two charges are in considering in this device. Okay, these two devices are magnetically coupling between the primary and secondary is very poor. The magnetically couple is very less or very poor. It results high leakage and between power factor. It results high leakage and low power factor. So due to that of an poor magnetic coupling and power factors, at that time automatically high leakage and low power factor will be rises. Okay. Okay, in this secondary case, secondary term, now here transformer secondary current is the density is exceeds 500 ampere per centimeter square. Then due to interaction of secondary current, which that an incoming of the existence of secondary circuit is open or pinch effect. The secondary circuit is interrupted. So automatically there is no winding, they just simply is shorted. At the time this circuit is interrupted, this effect is known as pinch effect. So a possibility of asking for 2 marks answer. Okay, pinch effect, define pinch effect. The secondary circuit is interrupted, this effect is known as an pinch effect due to that of an not present of an secondary winding. Okay, now this furniture is having some drawbacks. This furnace is having some drawbacks. What are that? We will see. It has run on low frequency. Just a name only indicate depending upon classification. This classification all types of drawbacks is an existing this one. That is a low frequency. It has run low frequency. Okay. Next, it suffers from pinching effect. It suffers from pinching effect because of an secondary circuit is shorted. Okay, it doesn't suitable for intermittent services. It doesn't suitable for intermittent services. Already this service has been seen in our types of loads: intermittent loads, continuous loads, and discontinuous loads. So already seen. Okay, and last drawback, doesn't function if there is no molten metal in the earth. Doesn't function if there is no molten metal. There is no molten metal of the earth. Okay, this is complete details about direct core type furnace. Okay, and next one is that keeping vertical core type induction furnace. Same, every parameter or every function can be explained with the help of a logical figure, otherwise logical graphical representation or tabular form. So depending upon which one is present, based on that one we have to express. Okay, now see about vertical. Just see that the picture is consisting of the different parts. Okay, now we'll see. In this furnace, magnetic coupling is comparatively better and power factor is high. Hence, it can be operated from normal frequency. Previous one is that magnetic coupling is very poor. Now here comparatively better. That is the only difference. Direct furnace as well as an vertical furnace. The difference is that the magnetic coupling is comparatively better and high power factor is high, hence it can be operated from normal frequency supply. Okay, the circulation of the molten metal is kept in around the by convocation of a currents as shown in figure. See that figure. Okay, now the choice of a metal for inner rings of the furniture depends upon the type of charges used. So based upon the charge particles, we have to use the material is sufficient or this one is going to be enough or it is sufficient. Likewise we have to express it. Okay, and next one is that the furniture can be filled be the suitable hydraulic arrangement for the taking out of the molten metal. Is a very important. The tank is going to be filled with which one? The suitable hydraulic arrangement for the taking of the molten metals. Okay. Next, this furniture is widely used for melting, refining of a brass and other metals. Brass and metals of a power factor is 0.8 to 0.85 with a normal supply frequency, and it gives as efficiency 75%. It is a standard size varies from 600 to 300 kilowatts. Sorry, 60 to 300 kilowatts. All single phases. All single phases. Okay. The next classification we will see next class. Okay, thank you.